Hello again. So we are back with more fun, and we are going to look at, go away, section P4, the prerequisite, P4 lines in a plane. So we are going to review lines, something that everybody thinks, easy peasy, I remember that stuff. And then when you go to try it, you find that you forgot a bunch of stuff. So we are going to go over lines. Very important. We're going to use lines throughout the entire semester. You're going to use them in calculus. You're going to use them in, if you're using Calc 2, you'll use lines. You'll do Calc 3, you'll use lines. Super important. Okay, so we need to pay attention to them. So if we have our Cartesian plane here, and we got a line. Oops, we should be good mathematicians. I'm not good about this. There we go. So this line has this point right here, which is called the y-intercept. At the y-intercept, it's very important to remember the x-coordinate is going to be 0. This one is called the x-intercept. And at the x-intercept, the y-coordinate is also going to be 0, like before. Whenever you're looking for an intercept, the other coordinate is always going to be 0, okay? So you want to keep that in mind. And this thing has a slope. If it's going uphill from left to right, let me do that. Okay. So if it's uphill from left to right, the slope is positive. If it's, oops, let's get another pretty color. Let's go pink. There we go. If the slope is downhill, if the line is downhill from left to right, the slope is negative. Oops. Slope is negative. There we go. So uphill from left to right, positive slope. Downhill from left to right, negative slope. Important to remember. Okay? Now, when we calculate slope, let me make another graph here. When we calculate the slope of a line, the slope is the amount it increases in the y divided by how much it moves in the x. So it's referred to as the rise over the run. So if I have 2 points here, I'll make my little triangle like we did when we did the distance formula. This distance is the rise, and this distance is the run. I can also call it the change in y over the change in x. This is referred to as the Greek letter delta, and delta always means change. It might mean final minus initial. It might be 0.2 minus 0.1. It could mean a lot of things, but it means change, okay? So delta is change. So in this case, for the slope, if this is the point x1, y1, and this is the point x2, y2, then this distance here, like we did with the distance formula in the last unit, is going to be y2 minus y1. It's going to be the difference in the y coordinates divided by the same thing going this way, the difference in the x coordinates. And we use the letter m to represent slope. because slope is cool. That's why it's an M. So important for your little cheat sheet of notes? Absolutely. You want to have this somewhere where you can look at it and always refer to it so you can get the equation correct. Now let's use some points. 1, 4, and 5, 7. Here's 2 points. Let's calculate the slope. Oh, that'd be fun. Okay. Slope. So I'll call this point 2 and this point 1. So y2 minus y1 over x2 minus x1. Let me get rid of some of that. So that's going to be 7 minus 4 is 3. 5 minus 1 is 4. 3/4. Let's say we did it the other way. And I made this point 2 and that point 1. Let's try that. That'll be fun. So this would be y2 minus y1 over x2 minus x1. 4 minus 7 is -3. 1 minus 5 is -4. You still get the same answer. But now you've had to manage these negative signs. And if you forget about one of them and leave this off, you're going to say, oh, the slope is -3/4. Well, that is not correct. It is not -3/4, positive 3/4. I always look to the y coordinate and I pick whichever one has the biggest y coordinate, I make that point 2. So that at least I know I'm eliminating a negative in the top. You might get a negative in the bottom. You can't do anything about that. That's the way it goes. Okay. Now, let's say just for fun, we do it again, but we're not really paying attention and we do 7 minus 4 over 1 minus 5. So notice this is 3 over -4, -3/4. I got the negative because 5 and 7 are for point, in this case, 1. And, well, I guess we did it the other way. So this was assuming this is point 2 and that's point 1. Here's y2, 7, minus y1, 4. Oh, but then I got them messed up. I did 1 minus 5 instead of 5 minus 1. These 2 points should be at the same position in the formula, and these 2 points should be in the same position, just like they are here and here. Okay? You have to have the 2's together and the 1's together. It doesn't really matter what order you do, but you got to have those together so that you'll get the right number for the slope. So the place where people mess up is they just go too fast and they go this one minus that one and then this one minus that one. And when you flip a difference around, you get a negative sign and then you're sad. So you got to watch out for that. You got to be careful. Okay. Don't save. So now we know how to find the slope. If a line is really steep versus flat, this slope is big. This slope is small. Really steep, really big slope, close to horizontal, close to zero slope. And this horizontal line has a slope that's 0, no slope at all. Okay? Uphill positive, downhill negative. Okay, so we have a couple of equations here that we can use. And the one I like equation of a line, I like the, oops, slope intercept form. I try to always put the line in this form so that then everything looks the same to me. So all line problems, all linear equation problems look the same. And this equation you have seen before is y equals mx plus b, where m is the slope, and b is, boy, that's a cool y-intercept. So your y-intercept and your slope. And the game for finding the equation of the line in slope-intercept form is finding the slope, then plugging something into x and y and finding the y-intercept. This is how we do it all the time. Okay? Now there's another form of the line. Let me get another color so we're not confused. Okay, there is the general form of a line, and that is ax plus by plus c equals 0. Now, I can take this and I can do some algebra and make it look like this one up here if I want to. In fact, I will. If you give me in a general form, I'm going to change it to slope-intercept because this I understand. I know what a slope of 6 is. That's pretty steep. I know what a y-intercept of -2. Well, that's down below the x-axis. So this tells me more information. This doesn't give me as much. So I don't like this way. But that's another form of an equation. And so we can use that form as well. I prefer not. And lastly, a general knowledge thing is a 45-degree line. What do you know about 45-45 right triangles? I know you know something about them. That's right. The legs of the triangle are the same, right? These are the same length. These are both 45 degrees. You got a hypotenuse, a squared plus b squared equals c squared. But the important thing is the legs are the same length. So the rise and the run are the same. So if I calculate the slope of a 45-degree line, so it's rise over run, if these numbers are the same, this is always going to give me a slope of 1. So a 45-degree line always has a slope of 1. And that's how I can tell when I look at a graph. If here's my 45-degree line, a line like this might be slope of 3. A line like that might be a slope of, I don't know, 1/3 or something. A number smaller than 1 because it's less than 45 degrees. This is a number slope bigger than 1 because it's more than 45 degrees. So you can use that to judge the slope, and that helps a little bit to figure out when you're looking at graphs which line is which, okay? So let's talk about parallel lines. Parallel lines, I'll make one red and we'll make one green. Parallel lines, since they're parallel and the distance between them is not changing, parallel lines have the same slope always. So for line 1 and for line 2, the slope for line 1 is equal to slope for line 2. This is always the case. Parallel lines have the same slope. But, oh, let's see, where's the, if I write this in slope intercept form, Here's my y-intercept for line 1. Looks like a positive number. Here's my y-intercept for line 2. Oh, looks like a negative number. So they have the same slope, but different y-intercepts. And that's very important. So if I have a line y equals 2x plus 3, and I have a line y equals 2x minus 6. These are parallel lines because they have the same slope. And notice they have different y-intercepts. If I wanted to graph these two lines, the top one, see 1, 2, 3, there's the y-intercept. Its slope is 2, it's positive, so it's uphill. Here's kind of 45 degrees, so maybe it's like that. Oops, I missed a little, that's okay. And then the second one is a y-intercept of -6 down here, but still a slope of 2, so it's still parallel. So the y-intercepts are different, the slopes are the same, so the spacing between never changes, it always stays the same. Okay, parallel lines, same slope, different y-intercepts. I'm going to put a box around that because it makes me feel special. There we go. Okay, this is how you distinguish parallel lines. Same slopes, different y-intercepts. Okay, now perpendicular. So perpendicular lines are different than parallel lines because they're not parallel, they're perpendicular. So here's one, parallel, there's a line, and then here's a, hopefully I drew it, yeah, it's pretty good. Perpendicular line. This is a right angle between the two of them. Notice that for the blue line, the slope is positive. And for the gray line, the slope, it's going downhill, is negative. That's always going to be true. The y-intercept is here for the gray line, and the y-intercept for the blue line is here. Well, I could have drawn this line, let me see if I can do it, here, and it's still perpendicular. They could have the same y-intercept. That's okay. They have different slopes. Different slopes. And in fact, there's a very specific relationship between the slopes. If these are, if this is my perpendicular line, this is the symbol for perpendicular, okay? The slope for one line is going to be equal to the negative reciprocal, meaning -1/m perpendicular. Let me get a little space. There we go. So they're related very specifically. One of them's positive, the other's negative. If this one's 2, then the other one's going to be 1/2 or something. It's going to be different, but it's going to be related to this. Okay, is this important to put on your little cheat sheet? Absolutely. This is how you find the slopes for perpendicular lines. And this is how you're always going to do it for perpendicular lines. So let's do an example. Any questions? Okay, good. So if I have a line y equals 3x plus 7, and I want to know an equation of a line that's perpendicular to this, well, then the perpendicular line is going to have a slope here. My perpendicular line is going to be -1 over the original slope. So it's going to be -1 over 3. And do they have the same y-intercept? Maybe. Or maybe they have different. Maybe this is 146. I don't know. Doesn't matter. This part is what makes them perpendicular lines. We don't care about these numbers unless we're given some specific information that we have to use a special y-intercept. But the 3 and negative 1/3 is the relationship between the slopes. Now, I have seen people be fond of saying, here's my equation. What's the equation of the perpendicular line? And people get kind of flustered because it's a fraction and they go, oh my God. Let's see, negative reciprocal. So this one's going to be positive. I took the 3 and I kind of flipped it over to get 1/3. So it's the same thing here. This is going to be 7/2x plus 148,624.9. Any number here. We don't care what this number is. This is what determines that they are perpendicular lines, is the negative reciprocal of the other one. Okay? You could start with this line and you're asked what's the perpendicular one to that. If you start with 7/2, you flip it to make it 2/7, you slap a negative sign on front, and now you've created a perpendicular line to it. Okay? So let's try a problem. This will be, I promise, so much fun. Okay. Find a line parallel to 2y plus 4x plus 8 equals 0. Okay? So the first thing I'm going to do is I'm going to take this thing and I'm going to fix that. I'm not going to leave it like that. I'm going to try to get y by itself so I can get it in slope-intercept form. So I'm going to do a minus 4x minus 8 to both sides. So this will give me, these will cancel out. 2y equals, what was that? Minus 4x minus 8. And then I'm going to divide everything by 2. Y equals minus 2x minus 4. Okay, here's our line. Here's our slope. Here's our y-intercept. Okay, we're good. Find a line that's parallel. Okay, here's a new line. Minus 2x minus 3. Parallel lines, same slope, different y-intercepts. Okay? If I want to find a perpendicular line to this one, so a perpendicular line, oops, not lime, that would be y equals the negative reciprocal. Negative would make this positive. Reciprocal, flip it over, would make it 1/2. And I could have the same y-intercept, or I could have a different y-intercept. It doesn't matter. It didn't say. If it just says find a perpendicular line, it doesn't matter what y-intercept. In fact, you could put 0. You could leave that off. 0 is just a number like any other. Okay? Parallel line, perpendicular line. Okay, so let's try another problem. So this is problem 11 in the textbook. Who knows if this is on the web homework thing, but it says find a point, find the equation of a line to this thing, and we want to do it in slope-intercept. And I give you a slope of 2, and I give you a point that's 1, 4. Okay? We want to find the equation of a line. Well, that's easy. Y equals 2x plus b. We don't know what b is, but we know the slope was 2, so I nailed that. But now, how do we get b? I got to plug a point that I know that's on this line into this equation to solve for b. So I'll use this one. 4 equals 2 times 1 plus b. Oops. So 4 equals 2 plus b. I subtract 2. 2 equals b. So now I can write the equation 2x plus 2. This is the equation of the line that satisfies this requirement. Okay? Let's do another one. Let me find a good one. There's a good one. This is number 23. We want to find the equation of the line in slope intercept form. Okay, so that means y equals mx plus b. And we're given some points. -4, 5, and 4, 3. How the heck are we going to do this? Well, I know how to do m, right? We know the equation for the slope. That's y2 minus y1 over x2 minus x1. So I'm going to take the biggest y coordinate, this one. I'll make that one 2 and that one 1. And maybe we're lucky and we won't get any negative signs. So 5 minus 3 over minus 4, minus 4, minus 4. Lots of negatives. Not lucky. So 5 minus 3 is 2 over -8. So the slope is -1/4. Right? So now I know part of it. Y equals -1/4 x plus b. So now I'll pick a point and plug it in here. And I'm going to pick, I think I'm going to pick this one because it has no negatives. So I'll do that. So I'll plug in 3 equals -1/4. So I'm plugging this point into the equation. 1/4 times x, which is 4, plus b. 3 equals -1 plus b. Add 1 to both sides. 4 equals b. So now I know the y-intercept. I know the slope. So I can write the equation. Y equals -1/4 x plus 4. There we are. So I took the points. 2 points always make a line. I can get the slope. Then I can plug a point I know is on the line. And since I use these to make the slope, I know they're on the line. And so I can use that to find the y-intercept. But hold on just a minute. And we'll pause. Okay, we're back. I had a kitty cat emergency. Cat was climbing on something and was about to knock down a bunch of stuff in the basement here. I think that's everything for P4. Follow these examples. You should look at the examples. Look at the examples and see the examples in the textbook, as well as these examples here, and this should see you through the homework. If you have any questions, please reach out to me or come during office hours and I can help. Thanks. Bye.